Okay, everybody. So last time we were together, we looked at dealing out an entire deck of cards. So shuffling them up and then dealing them out one card at a time until they were all kind of laying out in front of us. At least that's how you can envision it. A row of 52 cards all dealt out. And we discovered that there are one heck of a lot of ways to do that. I mean, it's just massive, 80.7 million trillion. I mean, just absurd. There's the number right there. Now, what I want to do today, before we get too far into what we're doing, is I want to actually be able to show you where I got that number from. So just open up Firefox or any web browser you want. And I just type 52 with an exclamation point into the search bar and press enter. And Google understands that what I want defined is 52 factorial. I think you can actually spell out the word factorial too, but I love the fact that in the current time we can actually type 52 exclamation point and it knows what I'm talking about. Now here it's scientific notation, 8.06. And then you see this E plus 67. What that actually means is move that decimal point 67 places this way. So that's 10 to the 67th power, which trust me, and you can do it if you want to. Looking back at this number right here at the top, if you put the decimal place right there at between the 8 and the 0 and then move it 67 places, it'll end up down here. Again, that just gives you an idea of how massive that number is. Another way of looking at how massive that number is by using I'm going to open a window here, the big number calculator. Okay, I even spelled it wrong, but it knew what I meant. And this one right here is a really nice one. What it allows you to do is to do any kind of calculation like we just did, like 52 factorial. Now the trick is you can't type 52 factorial into this calculator. What I'm going to do is I'm going to put the 52 where the x is, and then I'm going to come down here to where it says x factorial and press that. And what that does is actually apply the factorial operation to 52, and there it is right there. You can actually copy, if you needed to, copy that number and then paste it into whatever document you're working on. But that's how I ended up calculating it for your video last time. But what I want to look at now is I want to change the experiment a little bit. I still want to deal 52 cards out of a deck of 52 cards, but check this out. Here's how it's going to be different. Instead of dealing out the first card and leaving it out, you're going to deal the first card out, make a note of it, then put it back in the deck and shuffle again. Then you're going to deal out the next card, make a note of it, put the card back in the deck and shuffle it again. Then the next card, make a note of it, put it back in the deck and shuffle again. And you're going to do this until you've done it 52 times. So just like with this experiment, you're going to have 52 cards eventually out in front of you. You'll also have 52 cards that you have dealt out in this experiment that I'm describing right now, except that some of them might end up being the same card dealt out again. For example, since you're putting the first card back in the hand, you can get that card somewhere else in the row, and we'll talk more about that later in the class. So this is the new experiment: number of unique ways to deal out 52 cards, allowing for repetition, not dealing out the entire deck one card after the other, but dealing out one card at a time and then being able to use that card again. So hopefully you've realized there are definitely 52 options for the first card, but now there are also 52 options for the second card, and there are also 52 options for the third card, and so forth and so on and so forth. So really, if you think about it as multiplication like we did with the factorial, which was 52 times 51 times 50 times 48, blah, 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 it's the same math in that you're multiplying, but it's 52 times 52 times 52 times 52, blah, 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 52 times. So you're going to have 52 52s, which this is exactly why we invented exponents, so we don't have to write that out. So it's 52 to the 52nd power, which ends up being this if you thought this number up here was impossibly big, trust me, it is. This one is that much more impossibly big. It's just a massive number. As a matter of fact, if we go back to our web windows and I type 52 to the 52nd power here, it's going to tell me, there it is right there. It's 1.7 times 10 to the 89th. And again, you might say, oh, 89, that's not that much bigger than 67. Then you have to realize something, that what these numbers mean here. 89 means you have to move that thing 89 places. The other one, we only had to move 67 places. I'm laughing out loud saying we only had to move it 67 places because that's absurd. That's still huge, which means we have to move this one 22 more places, which means that's 22 more powers of 10. So just, again, saying it out loud is no replacement for actually doing what this number actually is, and that's what it is. You now see how much bigger it is than 52 factorial. I mean, it's massively huge how big this number is compared to the last one. The last one was huge, don't get me wrong. 52 factorial is a massive number. But 52 to the 52nd is just that much bigger. It's just that much bigger. Both of them incomprehensibly huge. Now, what I want to focus on back here in the PowerPoint, again, is not so much the hugeness of the numbers, which is pretty rad, actually. I want to focus more on the mechanics of the mathematics and how we did the same math to figure out both of these questions, because we did. Yes, they are two different questions and they are two different experiments. One of them, you're dealing out an entire deck so that all 52 cards are laying in front of you. And one of them, you're dealing out one card at a time. But in both of them, it involved us multiplying numbers together. For example, in this one, we went 52 times 51 times 50 times 49 all the way down to 1. And in this one, we did 52 times 52 times 52 all the way down until we had 52 52s. Both of these experiments were solved or were understood mathematically by using something called the fundamental counting principle. And what this allows us to do is simply break an experiment down into its component pieces. If we can figure out how many ways to do each of those pieces, we can then figure out how to do the entire experiment. So I'm going to let you read this paragraph on your own. You can hit pause and read that if you want. Once you've read that paragraph, I'm going to talk you through the second paragraph down here. So to find the total number of ways to do the entire experiment, all you got to do is figure out all the possibilities of all the component pieces and multiply them together. So again, backing up to this, each of the component pieces of dealing out a card for this second experiment was 52 ways, 52 ways, 52 ways, 52 ways. For this one up here, for the original experiment, it was 52, 51, 50. But for both of them, it involved multiplying possibilities together. And we're going to focus on that for the next few videos and show you how the fundamental counting principle can be applied to other things besides cards.